Hello friends, in today's question, a block A of mass 2m is placed on another block B of mass 4m, which in turn is placed on the fixed table. The two blocks have the same length 4d and they are placed as shown in figure. The coefficient friction, both static and kinetic, between the block B and the table is mu. There is no friction between two blocks. A small object of mass m moving horizontally along the line passing through the center of mass of block B and perpendicular to its face with the speed v collides elastically with the block B at a height d above the table. So we have to find out two things. What is the minimum value of v, calling it as v0, required to make the block A to topple? And part B, if v is equal to twice v0, find the distance from the point P in the figure at which the mass m falls on the table after collision. Ignore the role of friction during the collision. So we have two blocks A and B. A has a mass of 2m, B is of 4m. The height of B is given as 2d. A small mass m traveling with velocity v along the line of center of mass of B strikes it at a height d from the table. The friction is only present between B and the table. There is no friction between A and B. So first we have to find out the minimum velocity of v required to make block A as topple, to topple rather. So in order to, you can say, as there is no friction between A and B, so the block A will topple if the total distance is given as 4d, and it is only going to topple in case this distance it has moved is 2d, then only they have tendency to topple. So this is block A and this is block B. So we have to find out the velocity of this mass m so that it forces block A to topple. And it is given that they collide elastically. So we say let velocity of mass m after collision is v1 and velocity of mass 4m after collision is v2. So as the collision is elastic, it means momentum and kinetic energy as well as coefficient will be conserved, and the coefficient of restitution value of E will be equal to 1. So we assumed that after collision the small m mass is going to have velocity v1 and the mass 4m is going to have velocity v2. Therefore we can use conservation of momentum So we have mass m traveling with velocity v and the initial is 0 for 4m, and final we have mass m traveling with velocity v1 plus 4m traveling with velocity v2. So this is our initial and this is our final momentum. So here m cancels out. So we can say v is equal to v1 plus 4 times v2. Let us call this as equation number 1. Now we are going to use conservation of energy. Kinetic energy, we have for small mass m, mv square plus 0 is equal to, after collision, v1 square plus half mass is 4m and v2 square. In this case, this is our initial and this is our final. So here m cancels throughout as well as 2, 1 by 2. So we can say our v2 square is equal to v1 square plus 4 times v2 square. Let us call this equation 2. So we are going to use equation 1 and 2 and find out value of v1 as well as v2. So using equation 1 and 2, we are going to get v2 will be coming equal to as 2 by 5 v, or from here we can say our v1 will be equal to 3 by 5 times v. So these are the velocity of v1 is the velocity of mass m after collision and v2 is the velocity of block B after collision. Now secondly, let me redraw the figure. So this is block B having mass 4m, block B, and this is a small mass m, and we have block A of mass m. So we have said that block B is going to move towards right with the velocity of v2. Okay. You can write it that after collision, block B moves with velocity v2 towards right. And as there is no friction between A and B, the block A will have the tendency to remain in its original position, as no friction is present between block A and block B. Block A will not move along with block B. Therefore, we can say block A will topple A will topple as block B moves through a distance Let us suppose that distance we are going to say is given as S, and we already said that block A will topple if the block B has moved a distance of 2d. You can say under this condition S should be greater than 2d. So let us call this equation number 3. Now it is also given that there is a friction between B and the table. And say as there is friction between block B and the table. Therefore, the frictional force is Fr, which will be equal to mu times the normal, and we can find out the value of normal. So we have this 2m, and we have block B of 4m. So block B has the tendency to move towards right side with the velocity of v2. So friction will be acting in this direction, and we are going to have a normal n in the upward direction, or we can say normal n will be equal to 2m plus 4m multiplied by g. Therefore, we can say that Fr will be equal to mu 2m 4m plus g. So this will be mu 6m g. So this is the frictional force between the block B and the table. Now, because of this frictional force, the block B will be retarding. Because of this frictional force, block B will have a retardation. And we say, let us suppose retardation, or we can say it will stop after some time. Therefore, we can use the equation that Fr will be equal to force into mass into acceleration, where this acceleration is nothing but retardation, where A is equal to retardation. So we have two equations for Fr. Let us call this equation number 4 and this is equation number 5. So using equation 4 and 5, equation 4 and 5, we get mu 6mg is equal to 4ma. Here m and m cancels out, and we can write that the value of acceleration A will be equal to mu 6g divided by 4. And we can solve it further, which we can do later on also. Okay. And we say that after traveling a distance s, suppose the block B stops now. Let block B travels a distance of s before it stops. So as it is going to stop, so we can also say its final velocity will be equal to 0, and initial velocity, as we already know, is given as v2. Therefore, we can use the equation v square equal to u square plus 2as. So final velocity is 0. So this will be 0. Initially is v2. A is the retardation, so minus 2as. So here we can find out value of s. S will be equal to v2 square divided by 2a, and we already know value of a. Substitute it here, we get v2 square. This will be coming as 2 mu 6g and 4. So we can cancel it out. This is 2 and this goes by 3. So we can say s is equal to v2 square upon 3 mu g. So this is the distance after which the block B is going to stop. Now we already know that s for the topple, the s should be greater than 2d. So let us call this as equation number 6. So using equation 3 and 6, using equation 3 and 6, we get v2 square upon 3 mu g is greater than 2d. From here we can say v2 square is greater than 6 mu g d, but we already know that v2 is 2 by 5v. So we can say but v2 is equal to 2 by 5 times v. We substitute it here and get the solution as, let me square it here, v square is equal to 4 upon 25 v square. We substitute it, we get 4 upon 25 v square is greater than 6 mu g d. To further solve it, from here we can say that mu is greater than 5 by 2 square root of 6 mu g d, and we are supposed to find out the minimum velocity, minimum value of v. So we can say the minimum value of v, which is also given as v naught, will be v minimum, which is also v naught, is equal to 5 by 2 square root of 6 mu g D. So this is the part A. So you can see this is the minimum value. This is the minimum value of V required to topple block A. Now let us do the part B. In part B, it is given that if V is equal to twice of V naught. So it is given that if V is equal to twice of V naught, or we can say it is twice into 5 by 2 square root of 6 mu g d. Here 2 and 2 cancels out. Therefore get V is equal to 5 square root of 6 mu g d. Now it is also given that we have to find out the distance. Okay, so here this is block B having mass 4m, and this is mass m traveling towards the right with the velocity v, and it strikes along the this height is given as d. So we say after, you can say, collision with block B, it bounces back with the velocity v1. So this is point P, and we are supposed to find out this distance. Let us suppose call it as x, and we say it bounces back with the velocity of v1. So we can use the conservation of momentum for v1 is the velocity of mass m after collision with block B. After collision with block B. So using conservation momentum, using conservation of momentum, we can say that our v1 will be equal to m1 minus m2 times u1 divided by m1 plus m2 plus twice m2 into u2 divided by m1 plus m2. Now herein the value of m1 is m and m2 is 4m. You can say m1 is equal to m, m2 is equal to 4m, and we have our u1, its velocity we found out is 5 root of 6 mu gd, and we have u2, that value is equal to 0. We substitute these values, we get our v1 is equal to m minus 4m and 5 root of 6 mu gt divided by m plus 4m plus 0. We can say we get v1 is equal to minus, and mm and mm cancels out, so we get 1 minus 4, that is 3, and 4 and 5, this 5 cancels out, so this all cancel out, we get minus of 3 square root of 6 mu gt. So here negative signs obviously tell that it will be traveling the opposite direction. Now you can say that, let me draw it again. So this is the height d, point P, and this is the distance x which we are supposed to find out, and it bounces back with the velocity of v1, or we can say its horizontal velocity is v1. Now we are supposed to find out the x. Therefore, the vertical distance traveled by the particle by the mass m is d. So let us say for the vertical motion, of mass m, we have vertical distance sy is given as d, and uy is 0, and we have ay will be equal to g. And we say t is the time of flight, we can say basically t is the time of flight of mass m, say p and q. Let us call this as point r. So time of flight of mass m from point r to q, or we can say for a vertical distance of d. So we can use the formula sy is equal to uyt plus half ay t square. So uy is 0, so we get this as half g t square, and the distance is given as, you can say, d. So here d is equal to half g t square. From here we can say t is given as 2d by g and its square root. So we can find out the horizontal distance. Therefore, the horizontal distance traveled by mass m from point P is equal to PQ, which is equal to x, or which we can write formula will be equal to velocity v1 multiplied by time t. So we can say x is equal to v1 we already calculated, is given as 3 square root of 6 mu gd, and we have time as square root of 2d by g. So we can write this as x is equal to 3 square root of, multiply it, we get 12 mu g d square divided by g, and here g and g cancels out, and we can take, you can say 4 2, so this can be written as x is equal to 6, d also is common, and square root of mu. So this is the horizontal distance traveled by mass m. This is the horizontal distance traveled by mass m from point P. So this completes the question. Thank you.